Dedicated electrical space is addressed in the National Electrical Code, specifically in Article 110.26. This article is applicable to locations other than dwelling units. This means it's intended for commercial and industrial settings, not residential homes. Dedicated electrical space refers to the area around electrical equipment that must be kept clear for safety and accessibility. It's about ensuring electricians and other qualified personnel can safely work on electrical equipment without obstruction. Several factors define what constitutes dedicated electrical space. Firstly, readily accessible. The electrical equipment needs to be easily accessible for inspection, maintenance, and repairs. This means there shouldn't be any obstructions blocking access to the front or sides of the equipment. Secondly, free from foreign objects, debris, and combustible materials. The area around the electrical equipment must be kept clear of anything that could pose a hazard, such as tools, boxes, flammable liquids, or dust accumulation. Thirdly, ventilated to prevent overheating. Electrical equipment generates heat, and proper ventilation is crucial to prevent overheating. The dedicated electrical space should allow for adequate airflow around the equipment. Fourthly, protected from dripping or leakage of liquids. Water or other liquids can cause short circuits and corrosion, so the electrical equipment needs to be protected from potential leaks or spills. Now let's shift our focus to industrial automated machinery. Industrial automated machinery often involves complex systems with multiple components. These systems often include multiple skids with process piping for water, compressed air, oil, and motor control centers and control panels located near the machinery. Considering these factors, the question arises: does NEC Article 110.26 explicitly apply to the power and control panels used in industrial automated machinery? The answer is not directly. NEC Article 110.26 does not explicitly apply to the power and control panels used in industrial automated machinery. However, since these panels are not located in dwelling units, the general requirements of Article 110.26 may still be relevant. Even if the NEC doesn't explicitly mandate dedicated electrical space for these panels, it's generally considered good practice to provide it. This is because the principles of safety and accessibility still apply. Other standards, such as NFPA 79, which is the electrical standard for industrial machinery, and UL 508, the standard for safety for industrial control equipment, do not specifically address the issue of dedicated electrical space. However, NFPA 79 requires that electrical equipment be installed in a manner that protects it from physical damage and environmental hazards. Therefore, let's talk about some interpretations and recommendations. It is generally considered good practice to provide a dedicated electrical space for power and control panels in industrial automated machinery. While NEC Article 110.26 may not directly apply, the requirements for clearance, ventilation, and protection from liquids should still be considered. Here are some specific measures to consider. Firstly, providing a physical barrier such as a drip tray to protect the panels from potential leaks. Secondly, routing piping above the panels with sufficient clearance to prevent dripping. Thirdly, installing the panels in a location where they are not exposed to excessive vibration or contamination. Fourthly, regularly inspecting and maintaining the panels and piping system to address any potential issues. Now let's discuss the concept of clearance around electrical equipment. Clearance refers to the unobstructed space required around electrical equipment to allow for safe operation and maintenance. The specific clearance requirements vary depending on the voltage level of the equipment. NEC Article 110.26 provides detailed guidelines on working space about electrical equipment. These guidelines specify the minimum distances required between the equipment and any walls, ceilings, or other obstructions. The intent of these clearance requirements is to provide enough space for electricians to safely access the equipment, perform maintenance tasks, and operate tools and equipment without risk of electrical shock or arc flash. When routing process piping near electrical equipment, it's crucial to maintain adequate clearance to prevent accidental contact or damage. The piping should be routed in a way that minimizes the risk of leaks or spills onto the electrical equipment. If it's necessary to run piping above electrical equipment, consider using drip trays or other protective measures to prevent liquids from falling onto the equipment. Ventilation is another critical factor in ensuring the safe and reliable operation of electrical equipment. Electrical equipment generates heat, and if that heat is not properly dissipated, it can lead to overheating, equipment failure, and even fires. The dedicated electrical space should allow for adequate airflow around the equipment to facilitate heat dissipation. This may involve providing ventilation openings, using fans to circulate air, or installing cooling systems. When designing the layout of electrical equipment and process piping, consider the impact on ventilation. Avoid blocking ventilation openings or creating areas where heat can become trapped. In some cases, it may be necessary to install dedicated ventilation systems to ensure adequate cooling of the electrical equipment. Protection from liquids is another essential aspect of dedicated electrical space. Water and other liquids can cause short circuits, corrosion, and other damage to electrical equipment. The dedicated electrical space should be designed to protect the equipment from potential leaks or spills. This may involve installing drip trays, using sealed enclosures, or routing piping away from electrical equipment. If it's necessary to run piping above electrical equipment, take extra precautions to prevent leaks or spills. Use high-quality piping materials, properly install and maintain the piping system, and regularly inspect for leaks. In addition to the physical aspects of dedicated electrical space, it's also essential to consider the importance of regular inspection and maintenance. Electrical equipment should be inspected regularly to identify any potential problems, such as loose connections, damaged wiring, or corrosion. Maintenance tasks such as tightening connections, replacing worn components, and cleaning equipment should be performed on a regular schedule to ensure the continued safe and reliable operation of the electrical system. When inspecting and maintaining electrical equipment, always follow proper safety procedures. De-energize the equipment before working on it. Use appropriate personal protective equipment such as gloves and safety glasses, and follow lockout-tagout procedures to prevent accidental energization. Ultimately, the best approach is to consult with a qualified electrical engineer who is familiar with the specific machine design and installation requirements. An electrical engineer can assess the specific risks and hazards associated with the installation and recommend appropriate measures to mitigate those risks. They can also ensure that the installation complies with all applicable codes and standards. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years and is widely adopted by state and local jurisdictions. NEC Article 110 covers the general requirements for electrical installations, including working space about electrical equipment. NFPA 729, or the Electrical Standard for Industrial Machinery, provides specific requirements for the electrical systems of industrial machines. It covers topics such as wiring methods, grounding, control circuits, and safety interlocks. UL 508 is a standard for safety for industrial control equipment. It covers the design, construction, and testing of industrial control panels and other equipment. Complying with these codes and standards is essential for ensuring the safety and reliability of electrical systems. Working with a qualified electrical engineer can help ensure that your installation meets all applicable requirements. Here are some additional considerations for dedicated electrical space in industrial automated machinery. Consider the specific environment in which the machinery will be installed. If the environment is harsh or corrosive, take extra precautions to protect the electrical equipment. Consider the potential for vibration. Vibration can damage electrical equipment and cause connections to loosen. If the machinery is subject to vibration, use vibration-resistant components and secure connections. Consider the potential for electromagnetic interference or EMI. EMI can disrupt the operation of electrical equipment. If the machinery is located in an area with high levels of EMI, use shielded cables and enclosures. Consider the potential for arc flash. Arc flash is a dangerous electrical phenomenon that can occur when there is a short circuit in electrical equipment. Take steps to minimize the risk of arc flash, such as using arc-resistant equipment and providing adequate clearance around electrical equipment. In addition to the code requirements, it's also important to consider the human factors aspects of dedicated electrical space. The space should be designed to be comfortable and safe for electricians to work in. This may involve providing adequate lighting, ventilation, and access to tools and equipment. The space should also be free from hazards such as tripping hazards, sharp edges, and exposed wiring. Proper planning and design are essential for ensuring that dedicated electrical space is effective in protecting electrical equipment and personnel. In summary, while NEC Article 110.26 may not explicitly apply to power and control panels in industrial automated machinery, the principles of dedicated electrical space are still relevant. Following good practices for clearance, ventilation, protection from liquids, and regular inspection and maintenance can help ensure the safety and reliability of these systems. Consulting with a qualified electrical engineer is always recommended to ensure compliance with all applicable codes and standards.